Hey everybody, this is Paul. Welcome to part 3 of why does the derivative of x to the n with respect to x equal n times x to the n minus 1. So in this part we're going to be talking about the binomial theorem, and I went ahead and just wrote it down right here. And if you have no idea what this means, don't worry about it. I'm basically just going to explain the pattern of this in this tutorial, and I'll be kind of doing a quick example of how this works. And that's really all you're going to need to know in order to understand the proof of this right here. So basically what the binomial theorem says is if we have some term added to some other term, and then we raise that to some power, then it's equal to all of this stuff right here. So let's just go ahead and look at the pattern of what's happening here. So if you look right here, each one of these has a coefficient, and that coefficient is defined in terms of a combination. So if you don't know what a combination is, then you should go back to part 2 where I talk about combinations. So in the previous video I explained what a combination was. And so basically the combination is going to tell us what the coefficient of this polynomial is going to be, what the coefficients of each of the terms is going to be. So the top number in this combination is going to be whatever power we were raising our a plus b to. So for example, if we were raising this to the 5th power, then we would just have the number 5 all the way across the top of these combinations. Now, the bottom number starts at 0 and goes up to whatever power that we're raising it to for the very last term. So for example, if n was 5, this would be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, all the way up to the last term where we would have 5 choose 5. So that's the pattern of the coefficients right here. So now let's talk about this a part right here. So a is going to be raised to some power, and that power is going to be raised to whatever n is, whatever power we're raising it to for the very first term. And then the second term is going to be n minus 1, and then n minus 2, all the way down to a to the 0 power. So once again, for if we were raising this to the 5th power, the first term would be a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, all the way down to the last term, a to the 0. Now, the b part is going to be just opposite of that. It's going to start at 0 and end at whatever power we're raising it to. So if we were raising this to the 5th power, this would be b to the 0, b to the 1, b squared, b to the 3rd, all the way up to b to the 5th. So that's the pattern of the binomial theorem. So now that we've discussed the pattern, let's just go ahead and do a quick example. So for the example, what we're going to do is we'll just keep it a plus b. And what we're going to do is we're just going to raise it to the 3rd power. So if I just kind of follow this pattern here, this is going to be 3 choose 0, a to the 3, b to the 0, plus 3 choose 1, a squared, b to the 1st, plus 3 choose 2, a to the 1st, b squared, plus 3 choose 3, which is our n choose n term here, it's the last term, a to the 0, b to the n, or the 3rd power, since n was equal to 3. So now let's go ahead and simplify this. Now from part 2 I explained how to calculate the combinations. So basically if you were to calculate the combinations here, you would find out that 3 choose 0 is equal to 1, and 3 choose 1 is equal to 3, 3 choose 2 is equal to 3, 3 choose 3 is equal to 1, and then b to the 0 is simply equal to 1, so this is just a to the 3rd times 1, plus 3 times a squared, b to the 1 is just simply b, plus 3 times a to the 1st, a to the 1st is simply a, b squared, plus 1 times a to the 0, a to the 0 is simply 1, b to the 3rd. And so basically we can just get rid of all these 1s since they don't really change anything. So I'll just go ahead and kind of take those out. So let's go ahead and move that over a little bit, make it look a little nicer here. So this is really the answer right here, and we got it by using the binomial theorem. So a plus b, the quantity of that raised to the 3rd power, is the same thing as a to the 3rd plus 3 times a squared times b plus 3 times ab squared plus b to the third. So anyway, that's how to use the binomial theorem, and that was a quick example of basically how to do it. And so hopefully you guys understand the pattern behind this now, and you understand what this means now when you need to calculate something in this form. So anyway, we're going to be using the binomial theorem in part 4 in the next video so that we can explain why this up here is true. So we'll see you guys in the next tutorial. Thanks for watching, and have an excellent day. And if you haven't already, don't forget to subscribe.